So our objective today is to understand a line of best fit. What does it mean? What is it? How do we get it? So we're going to learn how to draw it. We're going to learn to come up with its equation. And we're going to make predictions using the equation. Don't worry about it right now, Joey. It has nothing to do with what we're talking about. So, first thing we have to do is understand the term line of best fit. Now, this only comes into play with one particular kind of graph, and it's the graph that we studied last week, which is a scatter plot. So, it's the line that best represents the data in a scatter plot. The line of best fit is the line that best represents the data in a scatter plot. So basically you have a scatter plot, and if they ask you to create a line of best fit, you're going to draw the line that best represents that data. So what are some things you watch out for? First thing you're going to do is try to get your line to fit so that there's an equal number of points above and below your line. Because not all scatter plots are linear, exactly linear and constant, that you can draw an exact line through them. Okay? But most of them are pretty reasonable with their positive correlation that you can draw it. So you're going to draw the line so that there are the same number of points above and below the line. So you're basically trying to draw your line through the middle of the points. Okay? Now, here's something you have to watch out for. There may not be any points from the data on the line. Your points may be distributed in such a way that the best way to draw the line is simply through the middle of those points, and they may not be a single point that's from the scatter plot actually on your line. That's okay. The other thing, don't worry about outliers. Okay, so outliers kind of throw off the data. So he's not part of, when you're drawing your line of best fit, you're not trying to make sure that your line passes through so the outlier and everything else, it kind of goes in the middle. It won't work. So you kind of ignore that there's an outlier. I think there's one here. Look on page 681 in your little packet. And you can see that there's a point at the 0 on the x-axis, and it's about halfway between 1,000 and 2,000. It's not on the line whatsoever. Okay? Notice that you've got points that are above, and then notice you have a couple of points that are exactly on the line, and you have a couple points that are close. Okay? So this line is best fitting the data. Now here's the scary bit. Every one of you may draw your line slightly differently. Okay? That's okay. I'm going to roll with that. And I will be grading everybody's stuff individually, okay, if you're not given specific information that's on the line. Okay? Homework tonight in the book, they give you information on 1 through 5, odd, that everybody's going to use the same points, everybody's going to come up with the same equation, everybody's going to be doing the same math, and everybody should come up with the same answer. Number 9, you're going to do a scatter plot, you're going to draw the line of best fit, you're going to come up with its equation. That's where we're going to have a difference of opinions on what the equation should be. Okay? Now, that difference in the equations is going to be small. Everybody's going to have a fairly similar slope. Everybody's going to have a fairly similar y-intercept. Okay? So that there's kind of this leeway based on what you guys come up with for those. So when outliers are present, I thought I had one on here. That other one wasn't so much of an outlier. I'm not worried to make sure that my line of best fit goes through all the data. It's going through the data that best represents that positive correlation. Okay? Now again, on that graph, there were 2 points from the data that were on the line. There were 2 that were close, but the rest of the points, the majority of the points, were either above it or below it. That's okay for a line of best fit. Okay, so the line of best fit is the line that best represents the data in a scatter plot. We're going to draw the line so that there are the same number of points above and below the line. There may not be any points from the data on the line, and we're not going to include outliers as we're trying to draw this line. So we're going to exclude them from our line. Okay? Next, how do we write the equation of the line of best fit? You're drawing a line. It may not pass through any points in your data. It may pass through 2 points. It may pass through 3 points. It may pass through 18 points. I don't know. It just depends on the data. So how do you write the equation of a line? Well, number 1, you need to identify 2 points that are on, that's underlined, the line of best fit. Not above, not below, but on. So we have 2 scenarios. Scenario 1, it may be a data point. It's on the line. So what I mean by data point, it's from the data they told you to graph this point. That point happened to be exactly on the line. Or you're going to look for a point with integer coordinates. So you're going to look on your graph and where did your line cross the intersection of lines of your graph paper. So when you're doing a line of best fit, you guys got to use a ruler so that you get an actual line that's straight. Okay? So you have both of these scenarios that could take place if you're asked to come up with the equation of the line. So identify the points. It could be data point that's on the line. It could be a point with integer coordinates. Okay, now again, this question is speaking mainly to number 9 on your homework and to number 8 on tomorrow night's homework. And then we're just going to continue with what we did for the last 2 days. We're going to find the slope of the line. And there's 2 scenarios that take place here when we're finding the slope. You may have a graph, and you may have had to draw the line of best fit. So if you're given a graph, you can do rise over run to figure out your slope. How far did you rise from the bottom point to the top point? How far did you run from that position to the actual point? Okay, could be right, could be left. If, however, you have 2 points of data, that's when you're going to use the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So again, it depends upon what the question is, what you can do. I still think just doing the formula is the easiest. And then you're going to use the slope and the coordinates of 1 point to substitute into our slope-intercept form, which is y equals mx plus b, and solve for the y-intercept. And that's precisely what you guys have been doing for the last 2 nights on homework, those of you who have done your homework. Okay, so you're going to be repeating that same process again. On questions 1 through 5, you're going to get the 2 ordered pairs. It's going to be kind of tricky how they give them to you, but they're still going to give you the 2 ordered pairs. On number 9, you're going to have to plot the data, make a scatter plot, draw your line of best fit, and then pick 2 points that are on that line that you draw, and then go through this process. Okay? Now, if that's all we were going to do, why do they make it so hard? Well, that's not what they're interested in. The whole point to scatter plots, Bree, sit up, please. The whole point to scatter plots is to make predictions based on the trend we see happening. Now, the packet and the new book use the word conjecture, which means an educated guess. And our textbook uses the word prediction because we're trying to come up with a thought of something in the future. Okay, so they basically mean the same thing. So that's our 4th step now, which is something you haven't done, is now we're going to make a conjecture prediction using the equation and an x value given to you. So, for example, we come up with our equation, and they may say, well, how many people will be in tennis in 3 years from now? And so you plug in the 3 years from now into the x spot and then solve. So they're going to give you the x because the y value is the answer you're going to be calculating. Okay? So we're going to actually use our packet, and we're going to go through an example of getting through the whole process to make a prediction. Okay? So let's look at question number 3 on page 681 in your packet. So this is the line of best fit packet. So what I'm not going to do is reproduce the graph for our notes because we're just going to be referring to this. And what I want us to do is to try to determine, are there 2 points that we can clearly see that are on our line? So we're either looking for data points that are on our line, or we're looking for where our line crosses the lines of the graph paper. So the best case scenario is being given 2 points. Okay, that are actually from the set of data. Do you guys see 2 points that would be on the line? Okay, what x coordinate do you see? I'm sorry, I can't hear. A 1, and what's the other ones? A 4. Oops, sorry. I don't know why I put a comma there. So on this graph, I see the point 1, and it looks like it's between 2,000 and 3,000. So this is, again, where you guys are going to have variations in your actual answers. Bree, we're on this page looking at this graph so that you can understand the steps that we're going to take. I'd appreciate if you would participate. So we're going to say that that number is about 2,500 for that point at 1. At the 4, gosh, it's between 4,000 and 5,000. It looks like it's halfway of halfway. So I'm going to put the number on of 4,250. Okay? So again, if you interpret those numbers to be different, then you're going to get slightly different slope. You're going to get a slightly different y-intercept, but the equations themselves would be very close to each other. If I graphed them on Desmos, you would see how reasonable they would be, provided you've done the math correctly. So there's our 2 points. Now let's go ahead and we're going to start with slope. So we're going to have 4,250 over 4 2500 over 1, connect and subtract. So let's see, that's going to give me a 0, a 5. Here, I'm going to do it over here. I don't want to make dumb mistakes. Rename. We get 1,750 over 3. Okay. And that ends up not going in evenly because the digits on top add up to 13. So I'm going to leave that as my slope. That's as far as I can go on that. So now I'm going to use that slope value, and I'm going to pick one of the coordinates. Let's pick this one because the numbers are smaller, and I'm going to plug it into y equals mx plus b. So the y value is the 2500 equals the slope, which is the 1750 thirds, times the value 1 plus the b. So I'm going to go ahead and use symmetric property, and I get 1,750 thirds plus b equals 2,500. Now I think more than ever, I definitely want to get rid of the fraction. So I'm going to multiply the entire equation, each term, by the denominator of 3. That's going to make that go away, leaving me with 1,750 plus 3b equals 7,500. And then I keep solving for b. I subtract 1,750 from both sides. That gives me 3b equals, I'm going to have to do some renaming, 5, do more renaming. I get a 7, and a 6 take away 1 is 5. And then I divide by 3. Okay. Now again, the digits there add up to be 17. So 3 can't go into them evenly, and I'm not going to rewrite this as a mixed number because I'm going to do some math with this. So I'm going to take these two values and write my equation. So we get y equals the slope times x plus the b value, 1,000 or 5,750 thirds. Okay. But if you look at part B of this question, it says use the equation to make a conjecture about the number of girls that will participate in ice hockey in the year 2020. So what we need to do is go back and interpret our graph. And if you look at the label for the horizontal axis, the x-axis, it says years since 1996. So year 0 is 1996. Year 1 would be 1997. Then we have 1998, 99, 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007. So 11 represents the year 2007. How many more years would it take to get to 2020? Oops, sorry. It would take us 13 years. So if we end with 11 representing 2007, 24 would represent the year 2000 or 2020. So what I'm going to do is I'm going to take this number and plug it in for the year number and solve this and see what we come up with. So I get y equals 1750 over 3 times 24 plus 5750 thirds. Ooh, we're kind of lucky, aren't we? 3 goes into 24 8 times. So then we get y equals, we multiply by 8, so we get a 0, we get 40, 56 and 4 is 60, so we get 14,000 plus this number here. Now I want to add 14,000 and this 5,750 thirds, so I'm going to go ahead and change this to a mixed number so I can get a ballpark idea. So 3 goes into 5 once with 2 left over, into 27 9 times, into 5 once with 2 left over, into 26 times, which is 18 with 2 left over, so I get 2/3 left over. So if I add those two numbers together, let's see, I get a 2/3, I get a 6, a 1, a 9, and a 15. So this basically, our graph has been about number of girls who participate in hockey. So what our prediction is that in the year 2020, there'll be close to 16,000 girls now participating in the hockey. So almost double what it is right now. So you could draw your conclusion and say about 16,000 girls will participate. And then, sorry for me running out of room, I'll put it over here. In ice hockey by 2020. Now, we don't know if that's going to be true or not, but based on the trend that we saw going on in this problem, based on the equation we came up with, and based on our calculations, this is what we predict happens. Okay? So that's how we solve these types of problems. Okay, so that's going to be one type of problem. So let me talk about what you're going to see on your homework. Now, this next problem you're going to have to write out so that you understand the background scenario. Is everybody done here? You good, Ken? Everybody good? I know most of you stopped writing because you think this is too much to do. Unfortunately, the high school thinks that you should know this. Common Core thinks you should know this. So here's our scenario. A college record in the 100-meter dash in 1960, and they use the T in parentheses, was 10.5 seconds, and they use an R in parentheses. In 1990, the new record was 10.2 seconds. Assume a linear relationship fits these data with ordered pairs. Let me correct this. With ordered pairs, T, R. Write an equation to fit the data and use the equation to predict the record in 2000. So what this problem does by telling you 1960 T is it's telling you here they want that number to go as your X value. And then when they wrote R after the 10.5 seconds, they want you to put that number as your Y value. So they're explaining to you here what the variables represent, and then here how to write them as an ordered pair. So even though it says T and R, you can kind of be thinking about it as being X and Y. Okay? Now, when we write our equation, we can't use X and Y. We have to use the T and the R because that's what they asked us to do. All right, so first thing we have to do is write the ordered pairs. So what's the first ordered pair that they have in the problem? Faith.
1960 and 10.5.
Okay, and what's our second ordered pair? Pete?
1990 and 10.2.
So now we have two ordered pairs. What do we get to do with them? What's in our list of steps? What do you know what to do when you're trying to write an equation? We're going to figure out our slope, right? So our slope is going to be 10.5 over 1960 and 10.2 over 1990. We're going to connect and subtract, and we get 0.3 over negative 30. Now, a lot of people have a hard time trying to figure out what this means, so here's the thing you can do. What could I multiply 0.3 by so that it becomes 3? Yeah, we talked about changing decimals into whole numbers, but if I do that to the numerator, I have to do it to the denominator. So that gives me, I'm going to put the negative up at top, negative 3 over 300, which simplifies to negative 1 over 100, or negative 0.01. So I'm going to use this value as my slope. Okay? Now I'm going to pick one of those 2 points, and it really doesn't matter which. So you're going to have to do a lot of math on some of these. So we're going to be using our spirals to do our work. And we're going to take a point and we're going to plug it into the slope-intercept form. So the y value is the 10.5 equals the slope, which was negative 0.01, times the x value, which was the 1960, plus b. And now we're going to solve it. So we have 10.5 equals negative. So when I multiply by 0.01, the number 1960 doesn't change. What changes is where the decimal point ends up. So I get 19.6, negative 19.6, because I had to move the decimal point left twice, plus the b value. Then I add 19.6 to both sides. And, oops. I get b equals 1, 10, 30.1. So now I put that together, and my new equation is going to be y equals negative 0.01x plus 30.1. This is your answer to A. There's your equation. Okay. Now we need to make a prediction. And it says use the equation to predict the record in 2000. So if right now in 1990 it's 10.2 seconds, what's the record going to be 10 years later? So all we're going to do for part B is substitute in, oh, by the way, I'm sorry, I didn't do that right. I have a boo-boo. I should have my R and my T, exactly. So what you do is remember how we wrote our equation. T represents X, R represents Y. So we say R equals negative 0.01 T plus 30.1. So that's your actual answer to A. For part B, we're going to calculate. R equals negative 0.01 times 2,000 plus 30.1. So again, I'm multiplying by a negative, so I'm going to get a negative, and when I multiply by 0.01, it says just move your decimal point left twice, and you end up with 20. All right, what's negative 20 plus 30.1? It's going to give you 10.1. So the prediction of what the record's going to be, or was going to be, in 2000 would be 10.1 seconds. And this is really the whole reason to understand scatter plots, is so that you can create a line of best fit and so that you can make predictions about things in the future. Like I was telling you, forecasting jobs are all about this, whether it's in sales or in the housing industry or in the banking industry. Like my brother's done all three of those. This idea is what he's used on all these different jobs to make a prediction of what should be happening next. Okay? All right, so that's it for today.